Okay, so in this one, the ratio is -1/2, and I'm just going to do it manually at first, just through these couple terms. So 3/8, that's our first. If we were just doing the series through one term, that's what it would be. If we were then going to add on that second term, that's what the sum of the series would be through two terms, 0.1875. Your third term, if you add that in there, now the sum of your series is 0.28125. Then if you do your next term minus 3/64, your next sum of your series through the first 1, 2, 3, 4 terms would be that. And we're supposed to do this infinitely, which immediately makes you probably a little hesitant. Like, how does that even make sense, right? How can you keep adding terms and expect this to have an answer, right? What's your gut tell you? The absolute value of these, of these terms? Okay, so as you keep adding on something, every term that you continue to add on gets closer and closer to 0, so what? So when you add them all, no, these individual ones are approaching 0. So as you keep adding them on, you're essentially adding on nothing. So it's going to converge on a number. Does this make sense? So let's keep going. What would be the next number I would add on? 3 over what? 128? Which, by the way, this is 2 to the 3rd power, 2 to the 4th power, 2 to the 5th power, 2 to the 6th power. That's 2 to the 7th power. Maybe we should just do it that way. There's the next one. The next one is minus. Do you also see how it's going back and forth between minus and plus? So the next one would be minus 3 over, if that was 2 to the 7th, and this is going to be 2 to the 8th. And then the next one is going to be adding on 3 over 2 to the 9th. And the next one is going to be subtracting 3 over 2 to the 10th. So as I keep adding these additional terms, what is this converging on if I add 3 over 2 to the 11th? Oops. Oh, man.
No.
Oh, no. Oh, no. Could you tell? Lauren says it's getting closer to 2.5. Let's do it this way. What was our series formula for yesterday? Let's do our series of this through 100 terms. And just let our calculator do it so we don't have to do it manually. What was our formula? A sub 1 is 3/8. 1 minus our r is -1/2 to the n power. We're going to do it for 100 this first time. All over 1 minus our r of -1/2. So let's just, rather than doing it manually, yeah, the ratio is -1/2. So as you keep multiplying by a negative and a negative, it's just going to keep flip-flopping. Okay? So 3/8 times 1 minus -0.5 to the 100th power. That's your numerator. Divided by 1.5. So through 100 terms, we get 0.25. What if we do this through 1,000 terms? Throw another 0 up there. Take that answer and divide it by 1.5. Also 0.25. So what Lauren was seeing before I accidentally erased the screen, when I was doing it manually, is that it was above 0.25, and then it was below 0.25, and then it was above 0.25 by less, and below 0.25 by even less. Right? And it kept going back and forth. I can go back up and at least show you the first few of these as we were increasing above 0.25 by about 3/100ths, below 0.25 by about 2/100ths, back above 0.25 by 7/1000ths, below 25 by about 4/1000ths. Does this make sense? Okay, so what's actually happening as your series increases, if I kind of give you this graphically, here's 0.25. When you first start out 3/8, if you're just doing the first term, it's up here. Then when you add on negative 3/16, it's down here. And then when you add on 3/32, it's above again, but by less. And then it's below again, but by less. And it keeps oscillating back and forth until essentially it's flatlining at 0.25, because as Andy pointed out, we're essentially adding nothing, because these numbers are getting teeny, 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 tiny. Matt?
So when it crosses 0.25, is that like in between two?
That would be like on the 1.3 term, which we don't talk about that. You're either on the first term or you're on the second. So it's almost hard to do it as a two-dimensional graph. It would, or not two-dimensional, continuous graph. You'd almost need to have individual points, but this is the pattern that you would see.
Can you do it with, like, can you do that equation with terms that aren't whole numbers?
Using our common sense, no. But if I plugged this formula into the calculator with an x as the 100, yes, it would graph that. But that's just an equation. The calculator doesn't realize that your variable has to be an integer. You can't have the 99.5 term. That just doesn't make sense. Okay? Any questions? Kind of a weird concept. There is a formula for this. Now, obviously, you can just plug in a really big number and do your series through 100 or through 1,000 terms, and it will probably have reached its tipping point by then. But there is a formula, and it's on the back right here. The sum of an infinite series. So in this particular case that we just did, that would be a 3/8 as your first term, all divided by 1 minus our rate of negative 1/2. So if I scroll this all down, 3/8, which gives us that 0.375, divided by 1.5, and you get the 0.25. Okay? This is saying that this only works if the absolute value of your ratio is less than 1. So what happens if the absolute value of your ratio is greater than 1, do you think? Infinity. That gut feeling you had that how can this work because we're going to infinity is the right gut feeling if your ratio is greater than 1. If you keep multiplying 2 by, let's say your multiplier is 3, so then you do 6, and then you do 18, and then you do 54, ... and you try to find the sum of this infinite geometric series, it's going to be infinity. Because these numbers are approaching infinity, and so obviously when you add them all together, that's approaching infinity tenfold, right? So you cannot use this formula. You cannot compute an infinite geometric series value if the ratio is anything other than really a fraction that's less than 1, or a fraction that's greater than negative 1. Does this make sense? Okay. So an application of this comes in politics, economics, and this actually happened under one of the Bushes. I don't remember which one. It was called like the government stimulus idea or something like that. Oh gosh, talk to your history. What's that? Yeah. So every working adult, and I'm sure there were some stipulations that you had to make over a certain amount in order to get this or something, right? It would make sense because a teenager who works part-time and makes $5,000 a year didn't get $2,000 back. But the government essentially sent out a check, gave everyone $2,000. I think it was $6,000 to be truthful.
Oh,
you remember this?
I know what you're talking about.
Okay, So that everyone got $2,000 if you were a tax-paying citizen and probably, were in any specific tax bracket. You essentially got a $2,000 check. And this was supposed to help stimulate the economy and help the government and the whole economy bounce back. So the idea behind this, and I wrote it there, but I'll explain it, is that if the average person receives a $2,000 check, they're going to spend it, right? Maybe not all of it, but they figure that somewhere on average, maybe people would spend about 70% of it. If $2,000 just shows up at your doorstep, you're going to spend maybe 70%. So that would entice me to go spend $1,400, right? So I would buy, ooh, this is fun. I would buy, if I had to spend $1,400, because knowing me, I just put it in a savings account and I would never spend it. But let's say I have to spend it or else I'll lose it. My $1,400, what would I buy? Oh my gosh. What? Blanket scarves. Oh, Patrick, we miss him. $1,400. What costs about $1,400? Maybe I'd buy an updated iPhone. No.
Are you serious?
I'd probably buy a new laptop. That's what I'd do. Because I hate the iPad. So I think I'd buy an actual laptop that I could sit on the couch with. Yeah, it would be a really nice laptop. That would be my bonus. Okay. So listen to the logic here. I would buy a new laptop and spend the $1,400. I'd buy a Dell. Who knows? Dell now just received $1,400. So the logic for Dell is they just got a $1,400 bonus. They're gonna go then spend 70% of the $1,400 that they received from me buying from them. So that's $980 I have. So then Dell's gonna take $980 and they're gonna buy, I don't know, they're gonna spend it on developing some new thing, right? Let's say they buy a bunch of little keys, right? And then whatever company makes the little keys just received $980 and they're gonna go spend 70% of that. Do we follow? So it's gonna be this domino effect, right? I give Matt $1,400. He's now going to spend 70% of $1,400 with David. David's then going to spend 70% of that amount with Lauren, and it's this domino effect all the way down until it kind of becomes nothing. Yes? Does this make sense? So every time this money is cycled through the economy with one more transaction, that's a good thing for the economy. So determine the total amount spent, sorry, typo, on consumer goods from the initial $2,000 tax rebate. This is essentially an infinite series because this is going to go on infinitely until we're pretty much out of 70% of a penny is you're out of money. So your series formula says take the first term. Now what would the first term be here? Be careful. What'd you say? No. Because they're asking how much is spent, and the first actual spending happens when I spend the $1,400. So just a little glitch to think about the technicality there. And then 1 minus, what's our rate? 0.7. Very good. So from that $2,000 rebate that they gave me, 1,400 divided by 0.3 is $4,666.67. That's how much money kind of got flushed through the economy. Just from, and that's just one person, right? So take, that 2,000 given to everybody and now flush it through the economy, $4,666 per person, and you've stimulated the economy. Does this make sense? Yeah, I think so. I don't know. You'd have to go.
Was that like after the...
True. That's true. And there are people like me that screw up the system because I wouldn't have spent it. I would have put it in a bank account. But here's the other thing. Did the government really give everyone $2,000? Yes and no. Because it's almost like they just cut the taxes by $2,000 for everybody that year. but they did it in a bulk check. So there's a psychological aspect to this, right? If they just cut the taxes and your paycheck was a little bit more every month, you wouldn't really realize it as much. But the majority of Americans are going to get a $2,000 check and they're going to think, awesome, what can I buy with it? Right? So that's the same thing with your tax refund. People treat the tax refund like it's additional income. That's not really. That was your money all along. The government was just holding on to it, right? But they get this tax refund check and they're like, ooh, what am I going to spend it on, right? Which is a good thing because we want people to spend it. The economy wants people to spend it.
They give it to like every working person or like every household?
I don't know. I'd have to look back at the details. I'm sure there was a lot of detail that had to be ironed out, but most working adults got it. Or most households, maybe it was per household, I don't know. But anyway, so we see just a kind of a real life application of where this concept is at play. All right, now for the fun stuff. Do you know what an annuity is? Have you heard of the word? Do you know what it is? An annuity just really means it's a type of investment account that you contribute to on a regularly scheduled basis. So not the type of account that you put $5,000 in and then you just never touch and then you never touch it again until 30 years later. But instead, I decide that I'm going to put $100 every single month into an account on a recurring basis. So that's really the only difference. But it's an investment, so there's also a percentage to be earned. So here's the formula. No, you don't have to memorize it. P is your recurring deposit. So that's your principal. That's what they will call principal in finance. That's the principal amount that you continue to put in there. R is your percent annual interest. N is the number of times compounded annually. That has to jive with the number of times annually you make your deposit, right, in order for this formula to work. So if it's compounded monthly, your recurring deposit has to also be monthly. If it's compounded quarterly, then your recurring deposit also has to be quarterly. So that will happen naturally. I'm not going to give you ones that don't work that way because I don't know what it would do to the formula. T is your time, and capital A is your final value of the annuity, which is just the name of this type of account. Okay? So in this first example, you're saving for retirement. You deposit $1,000 per month. What's that $1,000 going to go in for? P. Per month, and also this later on that we're going to read compounded monthly. Again, those are jiving. That's your N. Into a 401k for the next 30 years. So 30 is your T. If the interest rate is 5%, so R equals 0.05, and the money is compounded monthly, how much is the annuity worth after 30 years? Okay, so let's plug in our stuff. We have 1,000, brackets, parentheses, 1 plus 0.05 divided by 12 to the 12 times 30th power minus 1, all divided by 0.05 over 12. So before we crunch this number, all interest aside, after 30 years, how much of my money how much money did I physically put in the account? Not interest earned. How much money did I physically put in the account? How are you getting that, John? 30 years times 12 months a year is 360 months worth of contributions. 360 months of $1,000 is $360,000. So that's my principal investment. I should bring in one of my financial statements and show you how this all is presented on there. So that's my principal amount. That's what I contributed. Now, our total should be more than that, right, if we're making interest. So we go to type this in, 1,000.
We're going to get this formula.
Mm-hmm. So there's my numerator. divided by my denominator, I'm going to keep in parentheses 0.05 over 12, and my final account value after the 30 years will be $832,258.64. So that's awesome, right? I hope. Yeah, but no one's saving for 30 years because your kids only got to go to college at 18. But we're gonna get there, so I like where your head's at. Let's back up and show you 5%. No, it's not. Do you know what the stock market did this year? Over 20%. So 5% is pretty modest.
So if you go to a bank, it's 20%.
No, a bank is a totally different story. This is not a bank account. This is your 401k, your investments. This is the stock market. So your percentages are not no bank. Although when I first got out of college, you could make 7% on a bank account before all the corrections and crashes happened. Yeah. So anyway, here's what we're going to do next. I'm going to graph a function that'll show you how your annuity under these circumstances grows on a yearly basis. So I'm going to take out the 30 years and put in an X. Are you with me? I'm going to overuse parentheses because there's a lot of them. So my numerator is going to be in a big set. So 1,000, open my bracket, open my parenthesis, 1 plus 0.05 over 12, close that parenthesis, raised to the 12x power, minus 1, close the bracket, close the numerator, all over, open the denominator, 0.05 divided by 12, close the denominator. Good? That's the annuity. Let's also graph just my contributions. So I'm essentially contributing what per year? Per year. 12,000x. This linear one is going to be my contributions. Very steady, $1,000 per month, which is $12,000 per X years. And then the exponential one is going to be the annuity with interest involved. So here's our annuity. You can see the exponential growth. You didn't see it at first, right? It looks pretty linear at first, but over time, you see more of that exponential growth. And here is my linear contributions. So you see the significance of longevity, like actually giving it 30 years to do its thing. Exponential growth needs time. Early on, you're not going to see those benefits as much. You're going to be like, whoop-de-doo, I got an extra $5. Great. But over here, that's because your balance is low. So when you make 5% on a low balance, it's a low dollar amount. If you make 5% once your balance gets huge because you've contributed so much money, now you make 5% on a big amount and the gap starts to widen as your principal contributions go up. Does this make sense? Okay? So any financial advisor that you sit down with will show you kind of this sort of graph of assuming a 5% rate in all these circumstances. Now, a lot of this is the best estimate. 5% is very conservative, actually. It's probably 9%, 10% might be a little more realistic. If you did this 20 years ago, people would have said 20% is what you should be putting in there because that was more realistic and more common. But things have adjusted a little bit. Anyway, gives you the strength of exponential growth, but most importantly, over time. First 10 years, you're not going to see much, right? You're not going to see the benefits unless you just leave the money and let it sit and do its thing, okay? So, is this exciting? I love this stuff. What's going to be more exciting is finding out if $1,000 is going to be enough per month to cover, what did I say it was, $114 per year for one child to go to college, projected. Again, that's a projected number, but best estimates. $114 a year times 4 years means my little Patrick, oh boy, $456,000 to send him to college. So if I contribute $1,000 per month for 18 years, essentially, do we think that's going to be enough? I'll just plug in 18 here. Do you think it's going to be enough? What's that? Well, I'm not going to just type this in again. I've already typed in this monster once. I'm going to go back here, and I'm just going to do second trace, and I'm going to see what the value is at year X of 18, the 18th year. I'll see the value of this annuity, right? We'll assume the same thing. I'm going to do $1,000 a month, 5% compounded monthly, all that good stuff. So second trace value, if I type in 18, this will immediately give me the 18th year's balance. And we're trying to figure out if it's going to be enough. No. So I will tell you, because you're just, you talk to your financial advisors and you're like, well, would $1,000 be enough? And so I did ask them, was $1,000 a month good enough to put the kids through college? And they did all these computations, and no. They told me it would be that would cover about 70%. So now I'm curious.
Are you confident that your kids are...
Hold on, 349,202 out of 456,000, 77%. So saving $1,000 a month for 18 years. If, again, there's so many variables here, I'm not confident that projection of 114,000 is exact. It's definitely not. Software that does it, and it like tracks how college costs have been growing, and so if they continue growing at such and such a rate, here's what it will cost you in the year 2000 whatever.
Is that for like private schools or just...
This was for the college that I went to.
Oh.
They just said, let's assume they go to the same college you went to. So this number that I was given, 114, was calculated by software, by percentage growth, things increasing at the same rate for my college. What my college is now, how it's been growing, so what will it be? Best prediction. You can only plan for what you know. You can't say exactly that things aren't going to change, but this gives us the best ballpark, knowing what we know now.
How much did your college cost when you went?
I don't know. I didn't pay the full price. I got financial aid and like little stuff. I hope so, but I can't plan for that. Okay. He's sitting over here telling me, don't you think your kids are going to... I hope they do, but I don't know for sure how the whole landscape of financial aid and scholarships is going to change. I just don't know. So I'm going to plan for the worst because that's what I do. I prep for the worst, and then if I have extra money, Matt, good for me. Okay, so I'll only have 77%. So the question then becomes, and I did not ask this, but I'm going to calculate it right now. If $1,000 isn't enough, what would be enough? So what variable are we solving for? P. Yes? So if my grand total amount I'm hoping this becomes is what? 456. So 456,000 equals, I'm looking for a principal amount. I'm going to assume the 5% compounded monthly. How many years do I get to wait? 18 minus 1 all over 0.05 divided by 12. So we've never solved equations like this, but I don't think this will be too hard in general. Just don't let the numbers overwhelm you. What's the first thing we should do to both sides to start getting PL by itself? Luke. Sure. Put this over 1 and do this. Yeah, I would have just said get rid of the denominator by multiplying by it on both sides, but it's going to do the same thing. So 0.05 over 12. And so if I take that 0.05, thanks for doing my family planning for me, guys. Times 456,000, 1,900. That's a nice number. 1,900 equals P times that nonsense, which I don't feel like copying over. How do I get PL by itself? Divide both sides by that bracketed nonsense, right? So I'm going to do 1,900 divided by all of that bracketed stuff. So open for the denominator. Open for the 1 plus 0.05 over 12. raised to the 12 times 18th power minus 1. Close parentheses for the denominator. Moment of truth. Any guesses? $13,005.
Wait, are you allowed to?
So if I wanted to get exactly that amount of money, and if the percentage rate was exactly 5%, but we all know that fluctuates every year, so that's impossible, and if the college is actually going to cost exactly that amount, which is probably near impossible, that it's going to be exactly that amount. Maybe it's going to be more, maybe it's going to be less, I don't know. But I'm just planning for what, to the best of my ability to know, is going to be about this scenario. A lot of moving parts, but I would need to save $1,305.83 per month. Okay, great question.
Wait, I have a question.
So, wait, let's back up. So, if I have 2 children, and that's what I'm doing per month, times 2 kids, times 12 months, yes? So there's 2 kids, that's what I would have to contribute per month, times 12 months in a year. That would mean I'd need to put aside $31,340 per year to plan accordingly for 2 children. Let's go back.
Wouldn't it be less than double? Because the interest would.
It wouldn't matter.
The interest would build up more. Faster.
No one. I see what you're saying. Let me show you. If I put $100 into an account that makes 5% compounded monthly for 1 year, what does that become? 100 times 1 plus 0.05 divided by 12. That's $100.41 repeating cents. We're just going to do that. You're saying if I do 2 different accounts, 50 growing at that rate, and another 50 growing at that rate, and I just split up my 2 kids' accounts? Is that what you're saying? What were you saying? Right, so this is what each individual account would get. And so, you add that together, it's the same thing. Doesn't matter if you split it up. It's not what you're getting at. Yeah, you're not, then I don't think you're communicating. Let's try it again.
I know what he's getting at, but I can't explain it.
Come on, we have to be able to communicate. Nikki, tell me what they're trying to say.
As it increases, there's more money in that account making 5%.
So 5%?
Sure, yes. So, okay, so let's go back to this one. So, you're saying that I made, however much the difference is there is what I made in interest.
Yeah.
So if I had a second account, it's still going to just make double that amount of money. So this made approximately a little less than 300,000 or 500,000. Doesn't matter.
Does it really not matter?
It really doesn't matter.
Seems like
I think I get what you're saying. They're both going to compound in their own respective accounts.
But you're going to make, okay, if you have 2 accounts, and
regardless of whether they're split up or not, I'm still making 5% on $100. Whether they're in the same account or if it's one account with $100, I'm still making 5% on that $100. And I'm still going to make my 5% on the interest I earned there. Here I'm still making the same amount if it's split up into two different $50 accounts. It is the same. It does not matter. We can revisit that in a minute. But where was I going? Oh, what I wanted to ask you quickly was if that's how much I have to save, whether it's in the same account or two separate accounts, who cares? This is what I'm supposed to save for two children to get them to colleges that are going to cost that much. Now, how much of my salary is that? Because when I make a salary, I only take home maybe 70% of it. So whatever my salary is, I'm only taking home 70% of it, and I need that to be at least that much money in order to be able to even do this. Because this is post-tax money, right? So if I just take this $31,000, hold on.
Wait, but where are you even
Divided by 0.70,
Where are you gonna?
that's how much of my salary, technically, that's what my salary would have to be able to be to even afford this. Just to totally all go to college. Now, yes, I have a husband, okay, so I'm not worried. We're good.
And where are you gonna find a 5% interest?
But when you make a $45,000 salary, you're losing a whole boatload of taxes, and then you're only left with this much, and that all has to go to college to be able to afford that. Are we good?